Thank you, Hubert, for being here. It's a great pleasure to be interviewed by you, and we have common background. We both live in Oslo for some years. I'm originally from Macedonia, and you're from Poland. So, jak się masz? Kako si?
Mam się bardzo dobrze, a ty?
Dobrze, prosím.
We send you greetings to Poland, especially to Lublin University.
Yes, thank you to our friends, collaborators, and Professor Robert Reidak at the University of Lublin. See you there, hopefully soon. Hello, my name is Goran Petrovski, and I'm a professor and senior consultant at the Department of Ophthalmology at University of Oslo and Oslo University Hospital. Welcome to our little tour to our friends at the University of Lublin, Professor Robert Reidak. We'll show you a little bit of what we're doing here and looking forward to collaborating with you. I will show first our two PhD candidates, Katrine Hollen and Mia Karabeg. They're both working on the diabetic retinopathy screening project, and Katrine is a nurse. She's taking the nursing aspects of the care in the screening, while Mia Karabeg is an optometrist, and she is actually analyzing the fundus images, among other things, manually by an optometrist, by a nurse, by an ophthalmologist, but also by artificial intelligence. So you can probably zoom in on some of the analysis which is currently ongoing with an artificial intelligence. Mia, how long does it take for this analysis to be actually done when you press the button for the analysis?
About half a minute, so we get results. So if you want, I can show you in practice.
So this is how we actually register these images. We take 4 of them, 2 for each eye, and then they're being loaded up in this software for the analysis. In the future, this could be done actually as a telemedicine consultation, and also taking other images, other parameters to risk stratify the patients.
It's processing, you see this line here, and in a couple of seconds we will get the result. You see this is positive for diabetic retinopathy, and we can even look at this report. You see that the right eye is moderate, and the left eye there is nothing, and there is nothing in macula either, and we can print this result here.
And now we're at the Cell Biology Lab at the Center for Eye Research and Innovative Diagnostics, where a lot of these innovative drugs and therapies are being developed. Currently we're looking at Dr. Santosh Gupta. He is working with retinal pigmented cells, which he's trying to make them chemically be more pigmented. Santosh, if you have a second in your busy pipetting of the cells, maybe you can say what is the significance of this work?
Yeah, so basically there is a disease condition called albinism where a particular type of cell in the retina are affected. They are either less pigmented or the pigmentation is completely absent. So here we are developing a therapy which can be used to increase the pigmentation in cells, and eventually it can be used to improve the vision in albinism patients. So
yes, this is one part of our large palette of projects that we have also in basic and translational research. And this is another field which we would love to collaborate with our colleagues in Lublin, Poland. Yes, and here we have Dr. Natasha Josifovska. She's one of our senior researchers in the department. Can you tell us what you're working on, Natasha?
I work in the eye field for the last 10 years, so I work with different segments of the eye, the cornea, retina, investigating retina pigment epithelial cells, corneostroma cells,
Fantastic.
I'm working on a different projects.
Fantastic. As I can also add, she's developing these decellularized corneas, which can be used in the future for transplantation. And she's originally from Macedonia, so we will greet our Polish friends and colleagues in Macedonian. Pozdrav od nas, od Oslo. Pozdravujeme Makedonците, našите braća Poljaci.
Hi, I'm Bjørn Helland Hansen. I am an ophthalmologist and a PhD candidate here at the hospital, being supervised by Goran. And I'm really excited, about this project that we're doing on validating this machine and showing, how useful it can be in clinical practice. I also work as the Chief Medical Officer at Bulbitech, and I'm so part of developing this device and its tests.
Here is an opportunity to test the Bulbicam. It's not many places in the world. This is a Norwegian company, Bulbitech, which we're co-developing some tests and validating some of these tests. And Bjorn is an ophthalmologist who is developing these modules. Maybe you can describe a little bit the Bulbicam.
Yeah, thanks. People are always amazed when I tell them that, how many percent of all sensory information comes in through the eyes? And people often think it's 30%, 50%, but no, it's 80%. And also the eyes are the only sense that actually gives feedback. You can see on the eye what happens in the soul, so that's why you call the eyes the window to the soul. And we have made this machine that can actually read these responses. So Goran, if you would come in here. And basically we have made a machine that reads your eyes, and I kind of joke that we can read your thoughts. And that's not quite true, but we can actually read if there's something wrong with your thoughts, because if you have dementia or a lot of other brain diseases, they will actually affect your eye movements. And also inside the eyes, if there's something wrong in the eyes, it will influence how we use our eyes, and we can actually read it through here. So this is a great, additional technology, because if you want to buy a car, you can go on the newspaper and you see some photos of the car, but no person in their right mind would actually buy that car without test driving it. While in ophthalmology, we mainly take pictures, and there's only one or two things where we actually test drive the eye, visual acuity and sometimes visual field. But here we are actually test driving the eye in many more ways, and so we get a lot of additional information here. He is actually looking at a very nice view of a summer field. I wish that was like that in Norway now. And here we are tracking the eyes. So basically we can see where the eyes are moving. And then when I do tests, we see how the patient responds to those tests. And we actually have two PhDs working here at the hospital at the moment. So a colleague of mine, Alexander, he is working with glaucoma and cataract. I myself am working with diabetic retinopathy and AMD. And in another clinic nearby, they're working on Parkinson's and ataxia. And we show strong results in all of these areas. So basically, this is a little bit an eye doctor in a box. And we are really excited about the possibilities for using this in clinical usage.
As Bjorn said, this is a top-notch technology which is probably going to revolutionize the way how we examine, diagnose patients and get functional tests. This is something which is less done in these days, and I'm really thrilled to supervise these talented people like Bjorn, like Alexander in our department to work on such exciting projects. Good luck with Okobus.
Really good luck with Okobus. Wish you the best. And I'd love to test the device.
And put a Bulbicam inside the Okobus. The last but not the least, to our friends in Lublin, you have seen some of the technology with the Bulbicam a little bit earlier. And as you can see, probably as engineer before medicine, I love technology. So here we have actually the first world prototype of the Profundus adaptive optics camera. This camera actually has a 5 times wider field than the existing adaptive optics cameras in the world, and we work with a company, Profundus, in Sweden to develop it for analyzing the retina, but also other cells and diseases affecting the retina. So we look forward to establishing also further collaboration and having a network of these cameras in many places in the world, including Lublin maybe. Thank you, and greetings to our friends in Lublin and Professor Robert Reidak and his friends and the network.